Be they airplanes, satellites, or rockets, aerospace vehicles all have one thing in common besides their capacity to fly. Their internal construction includes several assemblies of tubes and ducts through which materials such as fuel, air, oil, and hydraulic fluid move. Aerospace tube and duct assemblies are typically made of highly durable, lightweight materials such as aluminum and titanium. The choice of material depends on the application. For example, whether the finished component must be able to resist high heat or withstand high pressure. These aluminum tubes are on their way to becoming a fuel line for a Boeing 737. The operator immobilizes a tube with clamps, then saws it to the length required. This leaves burrs, sharp shards, on the cut edge. So they insert the tube into a deburring machine. Here's what the tube looks like before deburring and after. They squirt some lubricant inside, then slide the tube onto the mandrel of a computer-guided bender. As the machine forms the tube to the required shape, the mandrel provides counterpressure, preventing the tube walls from collapsing inward. They'll repeat this process with all the tubes which make up the fuel line assembly. They clamp each part into a fixture, then pass a laser measuring device over it. With utmost precision, the laser analyzes the dimensions from 5 different angles to ensure the part meets technical specifications. Next, workers submerge the part in hot water and cleaning solution, then rinse twice. This washes away the lubricant and any dirt. Now the high-tech precision work can begin. A robotic laser cutting system finalizes the shape and cuts all the required holes and slots. Just a bit of pressure, and the cut pieces easily pop out. Meanwhile, a stereolithography machine makes the fixtures which will position the various parts of the fuel line together for welding. A computer-guided laser beam repeatedly flashes the shape of the fixtures onto liquid ceramic. Each flash solidifies a 0.1 millimeter thick layer of the liquid. Thousands of hardened layers later, the weld fixtures are fully formed. Welders use these ceramics fixtures to correctly assemble the connecting fuel line components. Once everything's precisely in position, the welding begins. For aircraft safety, it's critical that every fuel line be leak-free. To test for leaks, they fill it with nitrogen at high pressure, submerge it in a water tank, then watch closely for bubbles, which would indicate nitrogen escaping. They use nitrogen rather than air because its molecules are smaller, making it possible to detect smaller leaks. After this, they heat treat the fuel line to harden the metal and apply an anti-corrosion coating. They wrap the fuel line with high heat-resistant foam insulation, secured with high heat-resistant polyester tape. This insulation prevents fuel from freezing in cold temperatures. It also blocks heat coming from other components of the aircraft, keeping the fuel at a safe working temperature. After a final inspection, the fuel line is ready to be shipped to the customer. It leaves the factory with a few uninsulated spaces for installation clamps. These areas will get insulated after the fuel line is mounted in the air.